of properties to make different types of products. In this video, we're going to cover the next and last dot point for this chapter, which is this one. Analyze information from secondary sources such as computer simulations, molecular model kits, or multimedia resources to model the polymerization process. So you might have done something else in class, but we're going to cover the molecular model, this part here. You could have also looked at a computer model or done something else, but we're going to go, in this video, we're going to go over the molecular model kits. So what you might have done is you would have had these different models of, these are meant to be ethylene, so ethylene. The gray ones would be carbon, so the gray ones are carbon, and usually they're actually white. Hydrogen is usually white, but in this case it's green. And to model the polymerization process, remember these are all monomers, so each one of these is a monomer, each one of these. And to model polymerization, we have to make sure we can actually attach them end to end. So what we do is we break these double bonds, we break them, and once we've broken them, we can attach them end by end. Right, so break the double bonds. You would have done that with your molecular kit, and then attach them end by end, one after the other. And you would have had maybe 10 or so of these ethylene molecules, just to have a good demonstration of how it would look like. And so this would have been what you've done. You would have had your 10 or so molecules of ethylene, and you would have had your double bonds initially. You would have broken your double bonds to make sure you can actually attach them end by end. And this is what you would have had in the end. And this is another version of how it looks like in terms of more realistic version of what it looked like in class. And the reason why we do this is because models are quite useful. And first of all, it's hands-on. Some people are hands-on learners. So some people are hands-on learners, and that's a very useful way for them to really grasp the concept, because you do get a hands-on experience when it comes to models. Another reason why is because it's a simplified view. So someone might have not really gotten it when it comes to the theory, when it's in the text form, but as soon as they get their hands on some of these, like models, it makes a lot of sense, because it just shows the whole thing, but just a simplified version. And that's usually the first step to really being able to grasp a concept. So those are two reasons why models are useful in general. And some of the limitations, I wrote that they're not complete. And what I mean by not complete is that, for example, in this case, we only have about 6, 7, 8 monomers, which make that polymer. And obviously, usually an actual plastic might be hundreds of thousands long, but we can't really do that in class because we don't have the time. So it's not the full picture in terms of how long a polymer actually looks like, because those polymers are really, really long. And the other reason that I gave was that it's not the full procedure. So remember, for these procedures, there's usually a catalyst or a radical involved, there's heat involved, there's pressure involved. So because it's a simplified view, we can't get the full picture in terms of the model itself, but it does give us some basic understanding. So models are quite useful. Okay, that was basically all for this video. It was quite a short one. But just for what you should grasp, make sure you know whichever one you've done in class or this one, and get a reason why you've done it. So you might get a question in your exam, why are models useful, what kind of limitations are there, and maybe even be asked to describe one model you would have done in class as well.